So we're looking at the examples on the top of page 16. They ask us to find the measure of the angles formed by each pair of vectors. Right? So that's referring back to the formulas on the previous page. There we are. So I can snag that bad boy. So all we need to do is find the cross product. Well, I mean, there is a shortcut rule involving the cross product, but that's not necessary in this case. We're looking at the dot product between the two vectors that are given. So we have v, which is given, and then I, which is the vector 1, 0, 0. All right, so what we would want to do is find the magnitude of v, which is going to be 3 squared plus 5 squared plus 1 squared, for quality radical. And that we'll be able to use repeatedly. So 9 plus 25 plus 1, so we're looking at 35 under the radical. All right. The magnitude of I, that's a unit vector, that should just be equal to 1. All right. So we just need to dot the v and the I. So it's really just a matter of, we're adding the product of the corresponding parts, but there's a couple of zeros in there, so it's just going to become or result in a value of 3. All right, so theta would be equal to the inverse cosine of 3 over the magnitude of really v, because magnitude of I is not going to be overly relevant here, which is radical 35. All right, so we just need to compute using inverse trig that value. All right, so let me get my Desmos calculator here. So inverse trig division 3 over root 35. Inverse cosine is what I meant to say. No, inverse trig. I guess that's true also. So theta would be approximately 1.039 radians. All right. Now you kind of streamline the process, or learn to streamline the process a little bit. Oh, this diagram doesn't need to be here. That's for something else. I'll move that appropriately in a minute. I found it online and I wanted to make sure it got in the notes and just plopped it anywhere. All right, so we know that J is 0, 1, 0. The magnitude of J is what it is. Result of 1, because it's a unit vector. Same idea with K, so we're not worried about that. The dot product of V and J is just going to be a negative 5 here, so my theta is going to be the inverse cosine of negative 5 over the root of 35. So I could just do a quick, so about 2.577, 2.578 really, radians. All right, so that brings us to V and K, 0, 0, 1. All right, so that's going to give us, you can start cutting the fluff out here. The dot product of V and K is just a 1. So inverse cosine of 1 over the square root of 35, which is going to give us theta approximately 1.401 radians.